Hi, it's Mr. Anderson, and this is AP Physics Essentials video 101. It's on mechanical and electromagnetic waves. A good way to contrast these is to figure out, can they be transmitted through space, through an area where there's no medium or no matter? An example of electromagnetic waves that we can see are explosions on the moon. The moon keeps getting hit by meteors, and there are little flashes of light that NASA's been monitoring. One in 2013 was so bright that you could have seen it with a naked eye. Now, that flash is moving towards our eyes through space. It's electromagnetic. But it's also producing mechanical waves. So we would have seismic waves on the moon. If you were on the moon, you could feel those, the vibration through the moon surface itself. But since there's no air around the moon, no atmosphere, you wouldn't hear any sound. And in fact, if the moon were to explode, if you were to look at it in space, it would be totally silent. You could still see it because that's electromagnetic waves. And so energy is transferred through waves. Those waves can be mechanical or electromagnetic. Mechanical are ones that require a medium or some material or matter to move through. Electromagnetic don't. No medium required. Example of a mechanical would be sound waves. Example of electromagnetic could be light. And so mechanical waves require some medium to move through. So as you move your hands across the surface of water, water is the medium. You're oscillating the surface, and that energy is being transferred through the medium of the water itself. Example could be ocean waves. Sound waves work the same way. You can't see it, but there are air molecules. And so as I speak, I'm vibrating the air molecules. That vibrates the microphone, which vibrates your speaker, which vibrates the air around your ear, and so you can hear it. If there's no gas molecules around your ear, then you can't hear it. An example of mechanical waves are seismic waves, those that are produced after an earthquake, and this is a really cool study. So this was in 2011. There was an earthquake, you can see right here, in Virginia, and they were monitoring Twitter and looking for people who tweeted the word earthquake, and they just kept track of where those tweets were and how long it took for them to reach those people. And so you can see the seismic waves are actually moving out. You can trace where the earthquake went. Now what's interesting is that Twitter uses electromagnetic rays, so it's using electricity to transfer those messages. And so the U.S. Geologic Service is looking at Twitter as a way that we could have an early warning system so we could pick up and protect ourselves before those mechanical waves reach us. Example of mechanical wave that we're all familiar with is sound waves. So when you hit a bass drum like this, it's very loud, but what you're really doing is vibrating the surface of the drum, and that's vibrating, if we look at it, it's vibrating all the air molecules around it. And so we have these longitudinal waves that move out kind of in a three-dimensional sphere away from that bass drum. So that's vibrating your eardrum, and that's what you perceive as sound. Now, electromagnetic waves are different. If we look out into space, there's no medium there, there's no matter, but we're getting light from these distant stars. And so light or radio waves can travel through nothingness. Now they can still move through medium. So for example, light is moving through your room where there's gas, or could move through a prism. We could break it into its electromagnetic waves so we could see the different colors inside white light, but it can still move through nothingness. A good example of that would be using a vacuum pump. So if we were to put an alarm clock inside a vacuum pump, and we just have the alarm go off. And so the way this works is it vibrates back and forth, and you could ring the bells back and forth like this. But let's say we started to remove the air from inside the vacuum. What would happen as we pump the air out? You would still be able to see the vibration in the alarm clock, because that's electromagnetic waves, but pretty soon all of the gas would be gone. There would be no more sound waves being produced, and you wouldn't hear anything. And so did you learn to describe sound as a transfer of energy through a medium? And then can you contrast mechanical, which require a medium, and electromagnetic waves, which don't? I hope so, and I hope that was helpful.